Hello, everyone, and I welcome you all to another session of Python programming series. In this session, we will focus on unsupervised machine learning algorithm called as k-means clustering. In part 8 of Python programming series, I have introduced machine learning and also briefly discussed about supervised and unsupervised and the difference between them. And later on, there were many videos on supervised learning. We focused on two important algorithms that belong to supervised learning called as linear regression and logistic regression. This is the very first session on unsupervised learning. The one of the factor which distinguishes supervised learning and unsupervised learning is the type of data set which is used. In this slide, you can find two different types of data sets. Both are tabular data, but one of them is a label data set and other one is a data set without any label. So when you say label, it is nothing but the output variable or y. So this data set has x, which is nothing but the input features, and y, which is a label. So each example is labeled with the correct output. So supervised learning uses this data set, that is labeled data set, for training. Whereas in the case of unsupervised learning, it uses unlabeled data set. If you look at this data set, so you can find only features and there is no label or there is no output variable. In supervised learning, the objective is to learn from the mapping between input and output. Here it has to look for similar patterns in the data. There are different types of unsupervised learning techniques, and one of them is clustering. And in this session, we will focus on one type of clustering, that is K means clustering. Let us look at some of the real world examples for clustering, and movie recommendation system is one such example. In this case, the recommendation system suggests the similar movies to the users based on his genre and the actors and actresses he enjoys. Customer segmentation is another use case of clustering algorithm where the large customer database can be divided into different groups or clusters we call, and each cluster has customers with similar characteristics or preferences or needs. So this helps the marketing team to tailor their product offering as per the needs of the customers or as per the preferences of the customers. So these are the two real world examples of clustering algorithm. A means clustering algorithm, the data points are divided into k clusters where each cluster has data points or examples with similar patterns or similar characteristics. There are different methods to identify or determine optimal k value. So that we are going to discuss in this session. So we are going to use customer segmentation data set for training our k means clustering algorithm. And this data set is a tabular data in the form of a .csv file and which has got 200 examples and 5 different features. And the features are customer ID, gender, age, annual income, and spending score. Now, as you can see, one of the feature has a non-numerical value. So this needs to be converted into numerical values using label encoders. So that we will see during demonstration. So let us look at k-means clustering algorithm steps. The step one is to determine the value of k. There are different methods to do that. We are going to talk about elbow method during a demonstration session. So once, for example, the data points are given here, and we need to first determine the value k. Let's assume that the k equal to 2. That means we are going to divide these data points into two different groups called as clusters. And once we determine k, then we need a centroids for each of the clusters. So two centroids have to be selected. We start with the random selection. So that is step 2. Okay, so centroids are nothing but the center points of each cluster. So two clusters, so two centroids are to be selected. So once we do the random selection, now after that we have to start fine tuning these center points or centroids so that each cluster will have a centroid exactly at the center. So step 3, where what we do is we calculate the distance between each data point and the centroid. Here we use what is called as Euclidean distance, and we are going to compute a distance like this. Mu is nothing but the centroid, and j depends on the number of clusters that you have, and x are the data points. So each data point can have multiple dimensions, depends on how many features it has. Now this is how you find the Euclidean distance, and that's a formula which is shown here. So that is step 3. Once the Euclidean distance are computed, then we need to assign these data points to the nearest clusters. So there are two clusters, and we have computed the Euclidean distance. So now we have to assign each of these cluster. Let us say this data point has to be assigned to cluster 1 or cluster 2, depends on the Euclidean distance. So assigning the data points to the nearest cluster is the next step. Once that is done, so then we have to again recompute the centroids, because we randomly selected the centroids, but we want the centroid to be at the center of each cluster. So we recompute again so as to have a minimum what is called as within cluster sum of square distance, WCSS, which is also called as inertia. And this is the mathematical formula which is used to compute WCSS. And Sklearn, we're going to use Sklearn library functions for computing WCSS or inertia. So you can see that after recomputing the centroids, this is the centroid locations, and again it is not at the center. So again we'll have to repeat those steps of computing Euclidean distance, and again assigning the data points to the cluster. So those steps are repeated. Again the centroids are recomputed. Finally we'll get the centroids which are at the center of the clusters. So this is what we get at the end of these iterations. So this is how k-means clustering algorithm works. Let us look at the demonstration, and for this exercise I'm using Google Colab. You can use any other Python IDE. Now, very first thing, you need the data set. We're going to use mall customer data set, which I showed you earlier, and this data set has 5 different features: customer ID, gender, age, annual income, and spending score. The first thing is you need to upload the data set into the Google Drive. And before that, if you want to access any file from Google Drive onto your notebook, then first you need to mount the Google Drive. So now I have mounted the Google Drive, so I'll be able to see Drive, which is nothing but Google Drive. And I have uploaded my mallcustomers.csv file, which is the data set I'm going to use today for k-means clustering. So very important thing is you need to get the path. So you can click here and copy the path. So then you will have to paste it here. I have another video on pandas machine learning library. You can watch that. So the step 1 is to import the necessary libraries which we are going to use for k-means. So we need pandas library because we are going to use CSV file, and then for visualization matplotlib will be used. For creating k-means algorithm, for applying k-means algorithm, so we need sklearn and sklearn.cluster. Under clustering algorithms, you have k-means, and then we need to use label encoder for converting non-numerical feature, that is gender, into numerical features. So these are the various machine learning libraries that we need. So we have imported our libraries. So once you import all the libraries, then the next task is to load the data set. As I mentioned earlier, you can have your data set uploaded into Google Drive, and then you can copy the path and you can paste it here. And pandas function called pd dot read underscore csv can be used to read the csv file. So I have named this data set or data frame as data, and head function will give you the first five rows. It displays the first five rows. So if you look at this data set, we have five different features, and it is an unlabeled data set. It does not have any label or output variable. Now, one of the feature, that is gender, has a non-numerical value. So before we apply the k-means algorithm, or before we start training, we have to make sure that this is converted into numerical value. And for that, we are going to use a label encoder class or function. Now, once you have the data set uploaded into the notebook, so we can get information about the data set, and data is the data frame, and info function will give you the information about it. So it displays the number of non-null value. We don't have any null values here, otherwise you will have to handle these null values. You will have to replace them or remove them, etc. But here you can see that all the 200 values are non-null values. So once you get the information and analyze this, and you can convert the numerical values in non-numerical values into numerical values, especially for the gender. As I told you, it has male and female, which are non-numerical. So we can use label encoder, which actually replaces male by 1 and female by 0. So we can initialize the label encoder using this particular function, and then we can use a fit transform function. And in the data frame, so this is the feature which you want to transform, and you can save it back. I am not going to add another column. I'll be replacing the existing uh, you know existing feature, whatever it had, with the new one with numerical values. So if you just display this, you can see that now the non-numerical gender values are replaced by numerical values. So this is the next step. Now we have the data set, we have also transformed it. The next thing is that for this exercise, for mainly for visualization purpose, so I'll prefer two features to be used. And I'll pick two features instead of five. So I'm going to use annual income and spending score. So these are the features which I'm going to use. So you can extract these two features or these two columns from the data frame, and then you can save it as X. So X will be my new feature set, and rather than having five features, right now I have only two features, which are annual income and spending scores. So I'm going to train my k-means clustering algorithm with this data. So the once you have the data set ready, now it's a time to identify the k value. As I told you, in k-means clustering, k indicates the number of clusters, and there is a method called elbow method that we can use to identify the optimal value for k. So what we're going to use here is we're going to find out WCSS for k values ranging between 1 and 10. So we can have a for loop here, and we can use k means algorithm. We can initialize that with the number of clusters, and this is the for function, and that repeats 10 times. And so fit function will apply the k-means algorithm onto the data, or fit function is used for training the k-means algorithm on the data set. Then we can append all the 10 values using append function. So wcss dot append, and k-means dot inertia underscore. So this will be the WCSS, and then we can print it. You can see that these are the WCSS values for different k values, for k equal to 1 to k equal to 10. So this is what we're going to do next. Now, once you have the WCSS or inertia for the different k values, k equal to 1 to 10, and after that we can display them. So we can have the display. We can display where x-axis will be the number of clusters, that is k value, and y will be the WCSS. So you're going to get this particular graph, and this is the elbow point, and we can pick a k value from here. The optimal value can be picked. So you can pick a value somewhere here, 3, but so this is the ideal value. Again, the number of clusters depends on the application or the need that you have. It depends on the use case, but in this case I'm going to pick 5 as the k value. So number of clusters will be 5. In this case I'm going to pick 5 as the number of clusters. So once you have determined the number of clusters, now it is time to assign the data points or each example to that cluster. You can see that we have assigned. So we have initialized this with the number of iterations, so that you can give. To avoid future warning, you can give number of n underscore init, the number of iterations, and that you can give certain number to avoid any future warning. And number of clusters will be equal to 5 in this case, and we can train the model using a fit function. So then we can have a predict. So we can predict the clusters, and we can create a new column called as clusters. We had only 5 columns here, and this is going to be the sixth one, and that will be the cluster value here, which is the predicted values. Okay, so you can see that each of the example is assigned to a cluster value. Now, for example, the first example is assigned to cluster 2, cluster 3. So there are 5 clusters, as I mentioned earlier. Now, once this is done, we can also calculate the centroids. So this is the trained model. So dot cluster center will give you the 5 different centers. Each has x and y, because it's a 2D, two dimensional. X and y, x point and y point for each centroids are given here, and then we will be able to plot all the data points using a matplotlib scatter plot. And as I mentioned earlier, annual income in the x-axis and the spending score in the y-axis. And we are going to display the labels, that is nothing but the clusters. So we can see here. So here you can see that. So this is going to be. So these are the data points, and there are 5 clusters in 5 different colors. And also you can see that the center points or centroids are exactly at the centers. In this session, we learned about the difference between supervised and unsupervised learning. And also, we have seen some of the use cases of unsupervised learning, especially in the area of clustering. And then we discussed about k-means clustering algorithm in detail. We have seen all the procedure, and for the demonstration, we have used Google Colab. We developed k-means clustering algorithm using Sklearn, and the data set that we have used is mall customer data set.